For these videos, we're looking at the second fundamental theorem of calculus graphically. So we're letting big H of x equal the integral from 0 to x of f of t dt, where the graph of f is made of a semicircle and straight line segment. So we have our semicircle and two straight line segments. So this is the graph of f. Well, what if they ask for h of 2? It's important to come back up here and see where that 2 is. It's h of x, h of 2. So my 2 is replacing the x. So it's also going to replace this x. So h of 2 is equal to the integral from 0 to 2 of f of t dt. So this is the graph of my f, and I'm being asked to integrate from 0 to 2. So that is actually just finding the area from 0 to 2. Now because this area is underneath the x-axis, I know that it will be a negative. And then it is a quarter of a circle, so 1/4 pi, and my radius is 2 squared. 2 squared is 4, I'm dividing by 4. H of 2 is negative pi. What if I was asked to find h of 5? Well, x is being replaced by 5, so I will integrate from 0 to 5 of f of t dt. So I already know from 0 to 2 that it's equal to a negative pi. And then I need to add in the area all the way to 5. So I'm going to add this area in here. Well, the base of this triangle is 3, and the height is also 3. So the area is 1/2 times the base times the height. So 3 times 3 is 9, divide by 2, and we have plus 9/2. So there's my h of 5. Well, what if you're asked to determine the domain of h of x? For what values of x can you actually do this? Well, you can do it for any value of x that the function actually exists for. We are going from 0 to x, so we're starting here at 0. You can go to negative 2, or you can go all the way out to a positive 1, 2, 3, 4, 5, 6, 7, 8. So my domain is from negative 2 to 8. And I want to point out that while this h of x is the integral from 0 to x, they could have started this anywhere. So you really have to pay attention to your starting x value. We are starting at x equals 0 and integrating to some other x value. So the next question is, well, what are the absolute max and min of h of x? Justify your answer. So I'm going to start with saying absolute extrema take place at endpoints or critical numbers. I already know what my endpoints are. So I know that I'm going to have to find several values here. And one of the values I'm going to have to find is negative 2. I'm going to have to find h of negative 2. I'm going to have to find h of 8, I believe it is. But I also have to identify my critical numbers. So that's actually a question that comes a little bit later. I'm going to bring it in now. It says determine the critical numbers of h of x, justify your answer. Well, I'm going to start with the justification. I know that a critical number is when h prime of x equals 0 or is undefined. That's the general justification. Now, h prime is the derivative of our h, but h is the integral. So this is where the second fundamental theorem comes in. My h prime of x is the derivative of this integral, and it's from 0 to x. So you can imagine if we did the antiderivative, we'd have like a big F, plug in our x, plug in our 0, subtract. The big F of 0 would be a number, so we'd have a big F of x. So let's say it's big F of x, where big F is the antiderivative of little f. I'm sorry, t from 0 to x. We plug in our x, we have big F of x minus big F of 0. Well, when you take the derivative of this, the derivative of big F is little f. And the derivative of this is 0 because this is a number. So my h prime of x equals f of x, so it's actually this graph. This is my h prime of x. So what this really is the graph of a derivative. So where is h prime of x equal to 0? It's right here. So I would say x equals 2 is a critical number. And I know that because h prime of 2 equals 0. And that's enough. There's no place on here where h prime is actually undefined. It appears to be completely continuous. So while I'm on this, since this is the graph of h prime of x, I'm actually just going to finish out these other few questions. So we want to find relative max or a min. Well, I know that a relative max of h will be where h prime changes from positive to negative. If I look at this graph, the graph is negative here and it's positive here. So going from left to right, that never happens. But if you look at this critical number, h prime change from negative to positive, that's a relative min. So I would say there is a relative min, a minimum, at x equals 2. And I know that because h prime of x changes from negative to positive. Okay, we can also be asked about points of inflection. And we already know the justification for all of these if we're talking about the graph of the derivative. So a point of inflection is where h prime of x changes from increasing to decreasing, or decreasing to increasing. Now, when h prime is increasing, that means h double prime is positive. When h prime is decreasing, h double prime is negative, but we have the graph of h prime, not h double prime, so I'm going to stay with these words because that's clearly what I have here. So where does that actually happen? Well, this is the graph of h prime, so it's decreasing from negative 2 to 0, and then it's increasing from 0 all the way up to when x equals 5. So we have a change from increasing to decreasing right here, and then also right here. So I would say at x equals 0 and at 5. And those are my 2 points of inflection on the graph of h. Okay, so back to the problem we had just a second ago. We found our critical number, so x equals 2 is a critical number. So we know that we need to check also h of 2. Well, we already know what h of 2 is equal to. It's negative pi. We still need to find h of negative 2 and h of 8. So I can do that through the same process that I found h of 2. If I'm starting at 0 and I integrate, I got a negative pi because it was underneath and I was going from left to right. It's the same exact area if I go to negative 2 and it's still underneath, but I'm going in the exact opposite direction. So h of negative 2 is actually pi. And again, we knew h of 2 is negative pi, h of negative 2 is pi. It's a little confusing. If I stopped right now, this would be my max, this would be my min, but we also need to check h of 8. We knew h of 5 was negative pi plus 9/2. Well, I'm going to add in the other 9/2 to get this final answer out here at 8. So this is a negative pi plus 9. 9/2 plus 9/2 is 9. And if I look at the numbers, negative pi, it's a little bit more than 3, but it's negative, and I'm adding 9. That's still greater than pi itself. So h of 8 is my max, while h of 2 is my min. negative pi is the minute happens at x equals 2. So if I was asked what's the range of h of x, well, keep in mind h of x is not this graph. We know from the other page now that this is actually h prime of x. So when it's asking what's the range of h is defined as this integral. So it's asking what's the smallest number we can actually get for an area, what's the largest number for the signed areas, and we already found that. So the range will go from negative pi to, and I'm going to rewrite this just a little bit so it's 9 minus pi, because that's probably how it would look. And this would be the range of our h of x.